Okay, Algebra 8, we are moving on to section 2-4, multiplying rational numbers. So just remember that a rational number is basically any of the numbers that you guys are working with. Fractions or decimals are what we are going to focus on today. Oops, I think I skipped. Maybe not. Okay, so section 2-4. So I have just a model here so you guys kind of understand what it means to multiply a fraction. So to divide a square into four equal parts, and then lightly shade 3 of the 4, because we are taking 1/3 of 3/4. So we start with 3/4. Let me grab a pencil. Okay. And what it means, if we are taking 1/3 of the 3, well, there are 3 of them. If we just take one of them, that is 1/3 of 3/4. Okay, I like to use the word of when I do that. So this kind of basically just is breaking it down. So we're going to model a couple of these. So the first one, we're going to take 1/2 of 2/4. So let's break this into fourths. So if I have 2/4 of it, what is 1/2 of 2/4? Well, half of a half is 1/4. Okay, let's do another one. I'm going to divide this one into 6. So 6 is kind of trickier. First I divide it into halves, and then I divide it into thirds. Okay, sorry, my lines aren't very straight. There, it's a little better. So if I have 4 6, I'm going to shade 4. 1, 2, 3, 4. And so that's 4 6, and I want to take 3/4 of that. Well, 3 of the 4 would be there. So what is that? It's 3/6, which reduces to 1/2. Okay, the last one. I'm going to take 2/3 of 3/9. So first I'm going to break this square into ninths. So I'm going to do 2 lines here. That would give me 3, and then I'm going to break that into thirds too. So the first thing I'm going to do is 3/9 would be right here. Okay. Now I want 2/3. So there are 3, and I want 2 of them. So if I took 2/3 of 3/9, I'm really ending up with 2/9. So this is just to give you a good visual example of what we're doing. To multiply fractions, you don't have to draw squares. They're not all going to be that nice and easy. So what we are going to do is you multiply across the top and across the bottom, so they both have to be in fraction form. You cancel common factors in opposite, so like diagonally of each other, and then you multiply the remaining factors and pay attention if they're positive or negative. Okay, so for example here, we're going to do some examples together. So 2 and 4, they have a common factor of 2. So 2 can go into 2 one time, 2 can go into 4 twice. 1 and 9 cannot be simplified, so 1 times 2 is 2. 1 times 9 is 9. And 2/9 can't be reduced, so that's your answer. So 3 and 6, 3 can be divided by 3 one time, 6 can be divided by 3 twice. 2 and 7 cannot be simplified. 2 times 2 is 4. 1 times 7 is 7. 5 and 15, they can both be divided by 5. So 5 divided by 5 is 1. 15 divided by 5 is 3. 3 and 17 do not have anything in common. 3 times 3 is 9. 1 times 17 is 17. 9/17 cannot be simplified. So that's your answer. Negatives don't change anything other than your final answer, so I ignore them till the end. 3 and 9, 3 can go into 3 one time, 3 can go into 9 3 times. 2 and 10 can both be divided by 2. 2 can be divided by 2 one time, and 10 can be divided by 2 5 times. 1 times 3 is 3. 1 times 5 is 5. Positive times a negative gives us a negative. See, I don't want to have to take 9 times 40 or 2 times 27. So 2 goes into 2 one time, 2 goes into 40 twice, 9 and 27. 9 goes into 9 one time, and it goes into 27 3 times. 1 times 3 is 3. 1 times 20 is 20. Negative times a positive is a negative. Last one here. 7 and 21. 7 can go into 21, and 7 go into 7. 7 goes into 7 one time. 7 goes into 21 3 times. 4 and 8. 4 can go into 4 once, and it can go into 8 twice. 1 times 3 is 3. 1 times 2 is 2. Negative times a negative is a positive. I would also take 1 and 1/2 here too. Either way. Now some people don't like to cross simplify. If you don't, that's okay, but then it's going to be harder to simplify at the end of the problem. So that is all of your notes for example or for section 2-4. Let me know if you guys have any questions. Oh, I didn't do any decimals, did I? Okay, pause. I'm going to do a couple of your decimal problems off here. I'll do a couple really quick. Let's do number 18. So I always put the one with the most digits on the top, but in this case they both have the same amount of digits really, except those zeros don't do anything. So now you multiply like normal. You do not have to line up decimal places. 4 times 3 is 12. 4 times 5 is 20, plus 1 is 21. 4 times 0 is 0, plus 2. Now, I don't have to do any multiplying with the zeros because it doesn't do anything. But because there were 4 decimal places, 1, 2, 3, 4, I have to move 1, 2, 3, 4 places. So your answer is 0.0212. And it's a positive because there was no negatives there. Let's do another one. Let's do number 26. I'm ignoring the decimals for now. 3.04, 1.7. Okay. So 7 times 4 is 28. 7 times 0 is 0, so I add the 2. 7 times 3 is 21. Okay, then I'm doing my next number. 4 times 1 is 4. 1 times 0. 1 times 3 is 3. Then you add them together. 8, 6, 1, 5. Now how many decimals were there? 1, 2, 3. So I move over 1, 2, 3. So my answer is 5.168. Negative times a negative gives me a positive. Okay, there were a couple freebies for you, a couple decimals to give you those examples.